Lesson 3 has two parts. The first part is on evaluation of expressions. Then we'll review adding like terms. Now, let's talk about evaluation of expressions by just doing some problems. Look at practice problem A. I have that expression there, ab squared plus b. We consider that an algebraic expression. And that expression, it represents a single numerical value, as do all algebraic expressions. They don't look like single numerical values, but there is a way that we could get them into one numerical value. Now remember, when we study math, we're studying how numbers behave. That's one way to think about the study of mathematics. So how are these numbers a equals -1 and b equals -2 going to behave when we put them into that expression? What's going to happen? Are we going to get one of those to be the same? Are we still going to get a -1 or a -2, or is something else going to happen? That's what evaluation of expressions is about. We put numbers into an algebraic expression and see what happens, see what kind of a value we end up with. So let's do that. Let's take the -1 and substitute it in for a. And so we put in -1. Usually what I like to do on these evaluation problems is to put negative numbers in parentheses when I substitute them in. That helps me keep up with that negative sign. And that's just a really important thing in algebra, is to keep up with that negative sign, because if you don't, that's a way to make a really simple mistake. You just get your answer off by a sign change. And then b equals -2. Let's go ahead and substitute that in. And so we'll put a -2 here and square it because it was b squared. And then plus b, so we'd say plus a -b, or -2. Now we go ahead and simplify this, and we'll have -1 times a -2 squared would just be a +4, and then plus a -2, let's just say -2 instead of plus a negative. Okay, and then we'll have -1 times 4 is -4, minus 2 is a -6. So when we substitute a -1 and a -2 into that expression, we get the single value of -6 for a result. That's what you do when you evaluate expressions. You substitute numbers that are given into an algebraic expression and figure out a single numerical value result. Let's try another one here. Hopefully you're remembering how to do these evaluation expressions now. And remember, what I want you to do is, after we've done one or two of these, is to pause the CD and see if you can work it out yourself. So why don't you pause the CD and see if you can evaluate that expression there in B when x is -2 and y equals -3. And so all you do is substitute those two values in for x and y. X is -2, and so we would start with a -2 squared. Notice how I rewrite the problem just straight beneath, or write it vertically. That's what I like to say. I write the problems vertically, straight beneath the original expression. And so when you're doing your problem sets, you should write the original expression down, and that gives you a pattern to help you set up the problem. And you can identify, okay, am I putting the numbers in the right spots? And then plus y squared, put a -3 squared, minus x plus 3, so that'd be a -2 plus 3. Okay, and then go ahead and simplify that relationship. -2 squared, that would be a 4, plus a -3 squared, that would be a 9, because -3 times -3 is a +9, minus a -2 plus 3, so that would be equal to 1. So -1. And then we can do the rest in our head. 4 plus 9 is 13, minus 1 is 12. That's what that expression equals when x is -2 and y is -3. Now there's an infinite number of pairs of x and y values that we could substitute in to that expression. So it has an infinite number of answers. That's its answer when x is -2 and y is -3. It has that one and only one answer when x is -2 and y is -3. Evaluation is an important algebraic concept to know, and we'll be applying this later on in the textbook. Part B of this lesson is on adding like terms. Again, this is a review. This is something that was covered heavily in Algebra 1. And if you remember, like terms, those are ones that have similar variables with similar exponents for those variables. Now they could also just be constants too, like the 3 and the 4 in this set of numbers and variables. Or a better way to describe it would be a collection of terms. So let's go ahead and add like terms in this expression. You might have an expression in the book and it'll tell you to simplify it, and that's what they want you to do, is look for like terms. And so we see a 3 and a 4. We can add those together. Those equal 7. Now let's look for some other like terms. Well, we have a 2xy and a minus 5yx and then a minus 3z. Well, xy and yx, that's the same thing, right? Order does not matter in multiplication, and in a term like 2xy, everything's a factor, right? It's really 2 times x times y, or 2 times y times x. So either way, order doesn't matter in multiplication. And so the two terms I have highlighted there, those are like terms. Notice I have the negative sign in front of 5yx highlighted too. That's part of the term. Remember, in algebra we consider algebraic addition. We think of 4 plus a negative 5yx. So let's go ahead and add those. 2xy and a negative 5yx. That would be a negative 3xy. And then that z is by itself. There's no other term like it, so we just say negative 3z. We just add it on the end. And so that is the simplification of that expression. 7 minus 3xy minus 3z. Let's do one more. We have 3 terms here. This one's a little more complex than the first one. And when we have fractions like this and negative exponents, what I think is the best way to do these problems is to first simplify them by making all the exponents positive. So let's go ahead and do that first. Every single term, make the exponents positive. And again, I think it's a good idea to write down the expression on your paper. Don't just go from the book over to your paper. It's better to be able to work the problem vertically, and so you have all the information sitting there right above you on the paper so you can tell what to do next. And so we can just look at that, 6ab squared x to the minus 2, and then we can see that we need to make that x exponent positive, and so that would be 6ab squared over x squared, and then minus a times b squared over x squared, and then plus 3, move that a up, b squared over x squared. And so now we can tell that we have 3 like terms. Before, we couldn't tell for sure because the exponents were all in different places. And so now we have all the exponents positive. It's easy to tell that we have like terms. And usually that's what they want you to do on these problems anyway, is write the answer with all the exponents positive. That's usually the standard way to do them. So do that unless they tell you otherwise. So ab squared over x squared is our like term, the set of variables that they all have in common. And so we'll have 6 minus 1. Remember, it's understood there's a 1 there if there's no coefficient. 6 minus 1 is 5, plus 3 equals 8ab squared over x squared. And so those 3 terms simplified down to one term, 8ab squared over x squared. So like terms, they can be called like terms if they are just constants, or a single variable that's the same, or a group of factors, variables that are factors of each other, and they all have similar exponents. Each variable has the same exponent within that factor. And so we could tell that ab squared over x squared, that term was a like term because in each term the a was to the power of 1, the b was to the power of 2, x was to the power of 2, and it was in the denominator. Okay, well that's all for lesson 3.